Welcome to the third lecture on lists and iterators for ICS 211. Last time we talked about singly linked lists that have just a next pointer, and there's some issues with that because you can only, first off, you can only traverse to the next node. So if we have a pointer to the temp, we move to the next node. There's no way to get back to the previous node. You have to keep either going or start again at the beginning, and so that's not a very useful. It's very difficult to get backwards. Another issue with singly linked lists is you can only insert or remove after a node. So let's say we have temp pointing to this node. We can add a new node after temp, but we can't add a node before temp unless we move back to the node before temp. Similarly, to remove a node, we can't remove node temp because we have no way of assigning the pointers, so we can only remove after the node. We can't remove before temp, so we cannot remove before temp, which is a problem. So how do we solve these problems? We simply modify our linked node to include a pointer to the previous node. So now we know both who's next in the list and who's before us in the list. So here's an example of the code. Notice that all we've done is add a new private member variable previous, or prev, that points to the previous node or the previous item in our list. The constructor, simply we just need to initialize next and previous. So what does this allow us to do? We can now insert a node before any node that we have. For example, we are pointing to the node there. So what's the first thing we do? We create a new node, and then we assign a private variable inserted. We then want to set inserted's next to the correct thing, so next points to node, and inserted previous equals node previous. And so now we need to fix the pointers of the formerly previous node and node. So again, that's why we have node previous next now needs to point to the new inserted node. So node previous next now points to the inserted node, and node previous needs to point to the inserted node. Note that tricky node previous next. We are following the pointer, so the previous node's next pointer gets changed. And now we have a new node in the list, so we increment the size. We can now remove a node that we're pointing at. Just simply take the node's previous next pointer and point it to what the next node of the. So we skip over our node and we do the same thing with the node's next previous pointer, and we point it to node previous. Now the node is no longer in the list because as we traverse, node's not there, so we decrement the size and we return the data that we've removed from the list. So now we can create a DLinkedList class using this node. Notice that we keep track of the tail, because if we keep track of the tail, we can do a insertion at the end of the list at big O of 1, because we just do our insert there. We keep track of the size, and our constructor, we just have to keep track of the tail in addition to the head. The next idea in lists is this circular list. So here's a singularly linked list. We have a tail node so that we can insert at the tail the big O of 1. Traditionally, tail.next is null. That's how we know we're at the end, but if we keep track of tail, then we know what the end is. So what happens if we set tail next to head? So now there's no null pointer, there's no null next pointer, but now we can traverse from the list. We can keep going around the list. Now this is very useful when we're traversing the list, but it does cause some concern that it's very easy to implement or cause an infinite loop, that if you just keep looking for the null, you're not going to find it, and you'll just keep going around and around and around. So you got to check to see whether next is equal to head, or next, well, next is to head means you're at the end of the list, or the node you're at is tail. We can do the same thing with a doubly linked list. Again, we got to update both of the pointers. So head.previous points to tail, and tail.next points to head. And now we can traverse the list in either direction. We can go forwards or we can go backwards. Again, you have to worry a little bit about having an infinite loop, because you're never going to find a next pointer that's null or a previous pointer that's null that tells you the head or the tail. So you got to be a little bit careful about looping through that. So the idea of traversing or looping through a list is encapsulated in the iterator interface. Iterators allow us to iterate over a collection. All Java collections support the iterator interface. The idea is that you can iterate over all the elements in the collection. So there are 3 methods in the iterator interface. HasNext, it returns true if there is a next item in the collection that we have not visited. The next method returns that item and moves the cursor forward. And the remove method allows you to remove an item from the collection. It's an optional method that means that it may not actually be implemented. You have to implement the method, but you can throw an unsupported operation exception, because you must implement all the methods in the interface. So at the bottom we have an example of the cursor starts before the first item in the list. So if we called HasNext, the answer is true. So we return that first item and we update the cursor. So we just keep calling next. So if we get to this position, HasNext is true, we call next again, and now the cursor is at the end of the list or the collection, and HasNext is false. So that tells us we're done iterating through the collection. If we implement remove, we can remove the previous element that was returned. So the last thing that next returned can be removed from the collection. Not often used. It requires a lot more implementation. You have to remember the last one if you implement it. So I often just ignore that one. I don't implement it, just throw an unsupported operation exception. Now, for lists, we have an extension to the iterator that adds some additional information or additional methods. We have our traditional HasNext and our next, but since lists have indexes, items in the list have a position, we have the next index returns the index of the next element. We also have the idea of being able to go backwards. So what's the previous item, or is there a previous item? What is the previous item, and what's the index of the previous item? We also have some optional methods to add to the list. Add the element to the list, remove the previously returned item from the list, and replace the last item returned. Again, all 3 of these are optional, which means they have to be implemented, but you can throw an unsupported operation exception. So now that we can go forwards and backwards through the list, Java added an enhanced for loop that basically says, I want to loop over all the items in the collection. So I take the iterable interface, and what is that interface? It simply means you're going to return the iterator for the collection. So what this for loop does is it calls until HasNext is false. E is the parameter, is the next. So each time through the loop it calls next unless HasNext returns false. Thank you very much for your attention.